Today we are going to be talking about the definitions in section 5A. And 5A is a really good section in your book, and it's very, very word heavy. There's not really any math, it's a bunch of concepts and definitions. So in this PowerPoint, I'm going to be focusing on the definitions, but in the other PowerPoint that I have up on your Blackboard page, there's a PowerPoint with a whole bunch of example problems that are really good. They're written out in a lot of detail, so please go through that PowerPoint for examples. Again, in this one, I'm going to be focusing on the definitions. So we're going to be talking about statistics, and statistics is when we collect, organize, and analyze data. And one of the biggest things that we have to realize is everybody that we could talk to, it makes up the population. Population is every single person that we could possibly study. But typically the population is too big and too complex and would take too much time and money to actually get to everybody. So instead we typically study a sample, which is a smaller subset, and we hope that the sample is representative of the whole. So for instance, Wake Tech has about 40,000 students. It's unreasonable to go around and ask every single student their age, but I could very reasonably ask 30 students on main campus how old they are and say, well, these 30 students have an average age of such and such, so therefore all of Wake Tech is probably around the same age. If by chance you have enough information to study the whole population, we say that that figure is a parameter. So if we had access to the Wake Tech database that actually showed us the ages of every single student, and we could average them, that would be a parameter because it describes everybody. But we don't have access. I don't even have access to that. So instead, if I talk to 30 students on main campus and get their average age, that would be a statistic. A statistic describes a sample. And there's nice alliteration that population and parameter, as well as sample and statistic, they both start with the same letter, so that'll help you keep track of which one's which. So if you set out to do a statistical study, the first thing you've got to do is figure out what it is you're trying to study. You need to have a goal. And then once you know what question you're trying to answer, you need to figure out who you're going to sample to get data to hopefully answer your question. Once you collect the data, you'll analyze it, and then you'll use that sample to make some type of inference about the whole population and draw some conclusions from it. So again, we start with our goal, we figure out the population. We typically can't talk to the whole population, so instead we draw a sample. We get information from the sample called statistics. We make inferences about what we think the population parameters are, which lets us draw conclusions about the whole population. We really hope that our sample is representative. We really hope that our sample is a very good match to the whole population, just on a smaller scale. So some ways that we choose our sample, one is simple random sampling, where basically we put everybody's name into a hat and we randomly draw out some of them, and if your name got drawn, congratulations, you get to partake in the study, and if your name was not drawn, then you're left out. So simple random sampling works. I wouldn't say it's the most commonly used one, just because people tend to like to have a little bit more control, but you could put everyone's name in a hat and then just randomly choose some. Another thing that's pretty common is systematic sampling, and that's when you basically give everybody a number, or you put everybody in line, and you talk to every 10th person in line, or every 50th person in line, or every 100th person in line. You're choosing your sample on some regular interval. And I believe this is what they typically do at like the US border. I think they talk to every 17th person that comes in for like a very detailed, thorough check. And if you just happen to be that person, then you get checked out. Another way to sample is through convenience sampling, and that's when you just talk to whoever happens to be walking by or happens to be in your store. There's no rhyme nor reason. If they were there, then they get chosen. It's very convenient, hence the name. And then another type is stratified, and this is probably my favorite, because what you do with stratified sampling is you split your population up into groups. So maybe you would split it up into the guys and the girls, or maybe you'd split it up into different ages. So you'd have your people in your 20s and then people in your 30s and so on. And then what you do is you pick some people from every group. So if we had guys and girls, we would have some guys and some girls in our sample. Or if we split people up by ages, we would have some people from each decade of life in our sample. And what I like about stratified is it's still random who we're talking to, but we're at least guaranteeing that we're representing all viewpoints. So we're representing all the different groups of people. And here's some visuals. Simple random, we're just randomly picking people. Convenience, it's whoever happens to be walking by on this sidewalk. Systematic, we're talking to every so many people in line. And then stratified, we split people into groups and talk to some people from every group. What we hope does not happen is that there's bias. We do not want our study to be biased or skewed in some way. So sometimes we can have bias through like an observational study. And you can do an observational study without bias also, but just an example of how we could get bias. Let's say that you were going to survey people about who they're going to vote for in the next election cycle. Well, you would not want to go and sit outside, just say like the Republican National Convention, and ask everyone coming out, who are you going to vote for? Who are you going to vote for? Because you'll get a very different type of answer than if you talk to the whole population, or if you go and sit outside the Democratic National Convention and talk to those people. So you want to make sure, especially if you're doing some type of convenience or observational thing, that you're getting a good mix and you're not just getting whoever happens to be at hand, because that does give you bias. Alright, so types of studies we can do. I've already kind of talked about this one, but you can do an observational study where you're just sitting back, you're asking people questions, you're writing down their answers, or maybe you're watching them, but you're not really influencing in any way. Maybe you're sitting on a bench counting how many NC State hats walk by versus UNC t-shirts or whatever. You're just sitting back and watching, getting your data. And that's in contrast to an experiment where you actually do something and you're trying to measure the result of what you did. So if you do an experiment, we need to have two groups. We need to have what's known as a treatment group, and these are the people that actually get the medicine or whatever it is we're testing, and then a control group that doesn't. And we really want the treatment and the control group to be identical, except for the one thing that we're changing between them. So for instance, if you're testing a new weight loss drug, you wouldn't want to take the treatment group and give them a new diet, an exercise plan, and the weight loss drug, whereas the control group got none of them. Because if the treatment group lost weight, you wouldn't know if it was because of the diet or the exercise or the drug. If you really wanted to test your new drug, you would have needed to give the treatment group just the drug and kept everything else the same, and given the control group nothing, but again, keeping them the same. You want the two groups to be very, very similar, except for the one thing that you're testing out. And typically when you're doing a medical study, you have a placebo. And this is something that looks like the real thing, but people don't know if it actually has the medicine in it or not. So in our weight loss pill example, both groups would get a pill. It's just one of them would be empty and the other would actually have the medicine in it, so that there's not any like psychological effects making people lose weight or not lose weight because they know that they're getting medicine. They don't really know, so you're testing to see if the medicine actually has an effect. Because the placebo effect is when somebody thinks they're taking medicine and they improve even if they didn't actually get the medicine. You know, we've all seen this in our kids. If they fall down and they're crying, you can go give them a kiss and make them all better, and they're happy when you really just gave them a placebo. They think the kiss healed them when it really didn't do much of anything. But in order for the placebo effect to work, we need to have blinding. The people in the study don't know if they're taking the real medicine or if they're getting a placebo. So it's called blinding because they don't know who's who. And typically, the person giving the medicine out doesn't know who's who either, so that their body language doesn't give it away. And actually, that gets us to the difference between a single-blind study and a double-blind study. So a single-blind is when the doctor knows what's in the pills, and the doctor's giving it out to people, but the people don't know what they're taking. And the problem with single-blind is we're really good at reading people, and if the doctor knows, and you're saying, oh, doctor, I'm just not feeling any different, something in the body language of the doctor could give away if the doctor knew that, oh, you probably aren't feeling better because you're not getting the medicine, or you're not getting better, maybe the medicine's not working. Like, it could give away what's in your pill. Whereas in a double-blind study, the doctor doesn't know and the person taking the medicine doesn't know. There's a third party that is tracking everything, typically by barcode. So they get all the medicine, they put the placebos, the fake pills in boxes, and they put the real pills in boxes, and the boxes match, but they've got different barcodes on them. And then they mix them all up and they send some of everything to the different doctors' offices who then pass them out to the people. But again, the doctors don't know and the people don't know, but since everything's tracked by barcode, that third party does know, and then they can compile all the results and analyze it. And in this area, we have a lot of companies that do that. Quintiles, and RTP is actually one that I know of. They administer these double-blind tests. They get the medicines from the pharmaceutical companies, they send them out, they gather the data, and then they analyze it. Another type of study that we can do is a case-controlled study. And a case-control study is an observational study, but it kind of resembles an experiment because the people naturally divide themselves into groups. And an example of this would be studying the effect of smoking on pregnancy. You wouldn't want to tell some people, oh, you're going to smoke, and then other people, you're not going to smoke. You don't want to make somebody smoke or not smoke. Instead, what you would do is you would find some people that do smoke, that are smokers, and then you would find some other people that aren't smokers. The ones that do engage in the behavior are the cases. So the smokers would be your cases, and then the non-smokers would be the controls. And you could see the effect of smoking on the babies. But again, you're not the one making somebody smoke or not smoke. These people are coming to you as they are, and then you're working with them from there. So that would be a case-controlled study. It kind of looks like an observation, or it kind of looks like an experiment because you've got two different groups. But the difference is you're not putting the people into groups. They've self-selected themselves. And then our last definition is the margin of error. And we use margins of errors because we know that samples typically aren't exactly the same as the population. And we know that it's going to be a little off. There's going to be a little wiggle room. So the margin of error basically gives us an interval that we think the actual value is between. So maybe the average age of a group of 30 Wake Tech students was 26. So you think, this group of 30, their average age was 26, therefore the whole college is probably around there, but I don't know if I want to say it's exactly 26. I might say, maybe with a margin of error of 2, I would say it's 26 minus 2, which is 24, and then 26 plus 2, which is 28. So we might say, based on my sample, which had a statistic of 26 years old, I would think all of Wake Tech would be 24 to 28, giving myself a 2 degree margin of error because I'm letting myself be off by about 2 years based on my sample. So again, we just took our sample statistic, which was the 26 years old, and subtracted our margin of error, which I just said was 2, and we added it. So we got 24 to 28, and that gave us a confidence interval. Based on the statistic of 26 years old in the sample, I think the whole population's average is probably somewhere between 24 and 28. And again, we do this because our sample is not perfect, it's not going to be exact, and we need to give ourselves just a little bit of wiggle room because we don't have a great sample. So again, in this one, and I know I've talked for quite a while, I tried to go through the definitions and give y'all some quick examples. The other PowerPoint that's up on Blackboard and the section in your book are really good, and they have a lot more examples written out in great detail. So please read them and then post on Blackboard or send me an email if you have questions. I will be glad to help you from there.